If you're a science student or just someone fascinated by the raw power of our planet, then today's deep dive is absolutely for you. We're heading to one of Earth's most breathtaking and geologically active spots, Yellowstone National Park. But we're not just here for the geysers and hot springs. We're talking about something far more foundational, the seismic whispers beneath its surface, and what they might be telling us about its colossal volcanic system. Now, Yellowstone isn't just a park. It's a supervolcano, and it's constantly being monitored by a dedicated team of scientists. One of the primary things they keep an eye on is seismic activity. Earthquakes are a common occurrence in Yellowstone, often numbering in the thousands each year, though most are too small for us to feel. But for scientists, every single tremor is a piece of a larger puzzle, a potential clue to the dynamics of the massive magma chamber beneath. So, why are these earthquakes so important? Well, they're not just random ground-shaking events. Earthquakes in volcanic systems often provide critical insights into what's happening underground. They can be caused by the movement of magma or hydrothermal fluids, changes in pressure within the magma chamber, or the stress and strain on the surrounding rock as the crust deforms. Think of it like a massive subterranean plumbing system, and these quakes are the sounds of the pipes groaning and adjusting. Let's talk about seismic swarms. This is a term you'll often hear associated with Yellowstone. A seismic swarm isn't one big earthquake, but rather a series of many smaller earthquakes clustered in a specific area over a period of time, sometimes lasting days or even weeks. These swarms are particularly interesting because they can indicate fluid migration. Imagine hot water, steam, or even magma moving through cracks and fissures in the crust. This movement can stress the rock, causing these numerous smaller quakes. They're a natural part of an active hydrothermal system like Yellowstone's. Historically, Yellowstone has experienced several notable seismic swarms. In 2017, for instance, a swarm consisting of over 2,400 earthquakes occurred over several months near the northwest end of the caldera. While that sounds dramatic, scientists at the Yellowstone Volcano Observatory, or YVO, explained that this was well within the normal range of activity for the park. They diligently tracked its progression, using sophisticated seismographs scattered throughout the region, and concluded that it did not indicate an imminent eruption. This highlights a crucial point. Context is everything when interpreting seismic data. So how do scientists differentiate between routine seismic activity and something that might signal a significant change in the volcanic system? It's a complex process that involves integrating multiple data sets. They don't just look at the number of earthquakes. They analyze their depths, magnitudes, locations, and how they evolve over time. For example, earthquakes migrating closer to the surface, especially if accompanied by ground deformation, which they also monitor using GPS, could be a more concerning sign indicating magma ascent. Another key aspect is understanding the typical background behavior. Yellowstone is always active. It's not a question of if there are earthquakes, but what kind of earthquakes, where they are, and how frequently they occur compared to its long-term baseline. The YVO has decades of data, allowing them to establish these baselines. So, a swarm that might alarm the public is often, for them, just Yellowstone being Yellowstone. Now let's connect this back to the changes in Yellowstone's volcanic system. What kind of changes are we talking about? We're primarily referring to variations in the volume, pressure, and movement of magma and hydrothermal fluids beneath the surface. Significant seismic activity could be one indicator of these changes. For example, if we saw sustained, deep-seated earthquakes beneath the caldera, growing in magnitude and depth, coupled with significant uplift of the ground surface, that would definitely warrant closer attention. But it's rarely just one piece of evidence. Scientists use a multi-pronged approach. Besides seismicity, they monitor ground deformation using GPS stations and satellite radar, INSAR, which can detect subtle changes in elevation, whether the ground is rising or falling. They also track changes in gas emissions, especially gases like carbon dioxide and sulfur dioxide, which can indicate magmatic degassing, and they look at variations in heat flow, water chemistry, and even changes in the magnetic field. It's a holistic view. So, If seismic activity were to indicate a more significant shift, it would likely be one piece of a larger pattern. Imagine seeing an increase in earthquake frequency and magnitude, accompanied by a noticeable and sustained uplift of the caldera floor, and changes in gas compositions. That combination of signals would be much more indicative of a substantial change in the volcanic system, perhaps suggesting magma movement towards the surface. However, it's vital to remember that even these combined signals don't necessarily mean an eruption is imminent. Volcanic systems are incredibly complex, and magma can move around without reaching the surface. The good news is that the YVO is exceptionally thorough and transparent. They operate a world-class monitoring network and regularly update the public on their findings. They've repeatedly stated that there are currently no indications of an impending eruption at Yellowstone. The seismic activity we observe, even the larger swarms, aligns with the expected behavior of a large, active hydrothermal and volcanic system. It's a living, breathing landscape, and earthquakes are its heartbeat. In essence, seismic activity at Yellowstone is like the planet's pulse. It's always there, sometimes a little faster, sometimes a little slower. For scientists, learning to read that pulse is crucial. It helps them understand the inner workings of this incredible supervolcano and ensure that if genuine concerning changes were to occur, we'd have ample warning. It's a testament to the dedication of Earth scientists and the power of continuous monitoring. So next time you hear about earthquakes at Yellowstone, remember that it's usually just the park doing what it does best, being one of the most geologically active places on Earth. It's a vibrant reminder of the dynamic forces that shape our world, and a fantastic place for us to continue learning. Thank you so much for joining me on this exploration of Yellowstone's seismic activity. I hope you found this deep dive as fascinating as I do. If you enjoyed this video and want to learn more about geology and earth science, please hit that like button, share it with your friends, and don't forget to subscribe to the channel for more educational content. Your support helps us bring more science to curious minds like yours. See you in the next video.